know if I can be heard. I hope so. That is pretty cool. Nice. Okay, great. We got that going for us today. Okay, are we switching? Oh, wait. Yay. You know, it's never a Noku stream if something doesn't go wrong at the beginning. Alright, so I'm going to put Toho music because Toho music is hella lit. So like, yeah, screw you. Alright, so today I am going to be teaching Python. I'm going to be teaching how to program in Python. I think I have 3.12. Actually, it says it on the bottom. 3.12.3. Great. So, first, I guess, what is Python? So Python is a static, well, no, not static, it's a dynamic programming language. It's also both compiled and interpreted as a virtual machine. So that's cool. Python is also not known for being kind of slow, but it's very simple to use. So yeah. All right. And I'm just waiting for a bit more people to join, if ever. If ever. Like me. I don't understand. Your jokes are flat. Where did I leave my freaking fuck? Fun. Alright. So, well, I guess I'll start. Okay. So, there's if you want to learn to program, you have to understand that it's all about problem solving, and it's all about instructions. Right now, I'm going to be using Python, but everything that you learn in Python, you can pretty much use everything else. Maybe you should be looking at chat more. I am always looking at chat. I don't know what you're talking about. I mean, I don't know. You can ask questions. You're pretty much the only one here. Isn't that fun? Alright. Okay. So, first you gotta make sure that you have Python installed. Just, you can download it at python.org. You can get the latest version. Lies. No lies here. No lies. So, okay. I have no idea how I should do this. I am pretty much like throwing this. I am winging this. So, okay. First important thing to learn in programming is variables, and I guess data types. So you can define a variable in Python by just grabbing anything and then using an equal sign to assign it to any value that you want. This is a variable. Now there's certain rules to variable names. First, they cannot start with numbers. As you can see, that is completely incorrect. You cannot do that. You can use numbers as long as it doesn't start with numbers. So I can do this. I can be like, hello, 1. This is valid. You can also use things like underscores, which are very popular. But yeah. So those are variable names. So then variables can be multiple different types. So you have, in Python, you have multiple basic types, and then you also have basic objects. But I'm getting ahead of myself. So some of the more primitive types that you have in Python are what are known as ints, which are just ints, which are just whole numbers. I should probably like zoom in. There you go. So you have ints, which are whole numbers. So for example, equals 9, or b equals 10, or 1000. So those are ints. And then we have, I have no idea what I did. Okay. Then we have floats. So floats are numbers with decimals. So for example, 9.99 or pi, which is 3.141592653589793233846. So the thing about numbers with decimals in programming is the fact that floating point numbers are not very exact because computers have no concept of decimals. So in order to be able to properly represent them, we have to do certain trade-offs, and that means that doing something as simple as 0.1 plus 0.2 might not actually give you 0.3, which makes checking for values just very, very hard with floats. So that's one thing that you do have to be careful about. Alrighty. So, wow, okay, this is frozen. Yay. Alright, then we have strings. So strings is just text. For example, hello equals world. World. So text is defined by using the double brackets, but you can also do single brackets, and if you want to do a multi-line string, you can use 3. Oh, okay. You also use them for doc strings, but yeah. So it goes like this, and now I can do multi-line text. I don't know how to spell. So that's multi-line text, and if I remember correctly, I think you can also do it with like single quotes. Yeah, okay, you can do it with single quotes. Nice. So those are strings. Now, one thing to take into consideration is that strings are just they're just arrays of characters, but we'll get to that later. So then we have bools, which are just true or false, yes or no. um, on or off. Just as simple as that. To define a bool, you just use the special true and false keywords, and that's it. Those are bools. Very easy. So these are the basic data types that you can use. You can also make operations with numbers. So for example, I can do 9 plus 3. Or I can do 72 minus 14. Or you can do multiplication or division. Nice. This is obviously going to error out, but yeah, you know. You can also do floor division. So essentially what it will do is it'll divide the number and then it will round it down. So remove the decimals. Alright, so yeah, you can do operations. This would actually be pretty good if I use the REPL. So for example, I can do a equals 9 times 9, which should be 81. And as you can see, it's 81. I can do 23 plus 9, 32 minus 6. All kinds of operations. And of course, you can string them together and create operations like these. And it'll work fine. As I was saying, so 12 divided by 5, that's 2.4, but I can do floor division by using 2 slashes, and that gives me 2. Fun. Alright, so what else? What else is there? And of course, if you have variables that are assigned to numbers, you can perform operations with those variables like that. Easy. So then what else do we have? And also, fun fact, I'm pretty sure that you can do this. Yeah, so true in an operation actually equals to 1. And false equals to 0. So if I do something like false plus 1, that will give me a 1 because 0 plus 1 is 1. If I do true plus 1, that actually gives me 2. So that's the little thing about Python. It does not take it as far as maybe it doesn't take it as far as maybe JavaScript, which does some very, very shitty stuff, data type conversion. And yeah. Also, one thing that you can do if you have strings, like for example, I'm going to define a string that's called hello, and another string that's called world, that's got world. You can actually use the plus operator as a concatenator operator. What it means essentially is I'll put the two strings together. See? Easy. So what's next? So yeah, those are variables and data types. Then we have objects. So an object is just kind of like a thing. I don't know how to describe it. But an object is, I think I should hold off and explain functions first. Okay, so you can write your code, right? So I can do something like, for example, A equals 9, B equals 10, and then I can do print, which what it does is it shows something on the screen. If I didn't do this, I could do something like A plus B, but what would happen is what will happen is nothing, because I'm not telling the program to print anything. So I can just do print, and that is print is a function that just shows whatever you pass on to it. Nice. So print is a function, and a function is just a container for code that you can use. For example, let's say that I want to do a function that returns the sum of two numbers. So I can create a little function that just does print 9 plus 10, which is 19. Now here's the thing. If I run the program right now, oh wait, I didn't save. If I run the program, nothing comes up because I am not calling the function. That means that the function is being created, but it's not being run. To run the function, I have to type the name of the function and then two parentheses to indicate that I want to call the function. If I do that, boom, nice. And I can also declare variables inside of a function. These are known as local variables, and I'll explain why. So here I can do a plus b, and now I still get the same result. But here's the thing. If I try to print a plus b outside of the function, I will get an error. It'll say that a is not defined. That is because these are local variables and only exist inside of the function. What I can do to solve this is actually to take them outside and declare them here. So if I do this, oh wait, what? Oh wait, I think it's because I'm performing operations. Hey, where is it? Wait, what? Okay, there we go. Okay, so as you can see, now it works. But what's the problem? The problem is that anything can modify these variables. So for example, if I go here and I modify a to be, 90, you can see that the result is going to be different. So usually you want to avoid global variables unless they are variables that are important for an overall state. So now what I can do is I can just return the variables back to their function and everything is a-okay. And now if I do something like a equals 90 and then I call a function again, I am going to get 19 still, because this a is a local variable, so everything is okay. Wow. Give me a sec. Alright, okay, I'm done. Okay, I am done. That's what happens. Okay, I'll just come back, I guess. I should sit better. Alright. So I guess I'll just continue. And so, like, I barely have anyone. Isn't this fun? Okay, so Okay, but here's the thing. It doesn't matter how many times I call the add function. All I get is 19, right? But the thing is, the purpose of a function like add would be to add any sort of numbers, not just 9 and 10. So how can I do it to be able to get these numbers? Well, we can use what's known as parameters. So a function can have parameters. So here you can see that it's complaining that a and b are not defined. So in order to tell the function that it can accept external data, we can define parameters. The way in which we do it is just by putting them inside of the two squares here. But here's the problem. Now, if I try to call the function as normal, you can see that I get an error for missing two required positional arguments. So what that means is that now I have to pass it the data that it needs to work. So I can pass in 9 and 10. And now it'll give me 19. The thing is, I have to pass them both. If I only pass one, it'll still tell me that I'm missing something. And the same thing will happen if I give excess data. So if I give 3 when it only takes 2, the function will tell me that I'm giving it too much data. And so that's how it works. So right now, the thing is, we are taking the data, right? But what if I want to use that result, not just show it to the people? Well, a function can either do stuff or it can also return new data to use. What does this mean? So, by default, all functions actually return a value. What does that mean? That means that just as I can grab another variable, I'm going to call it c, and I can set it equal to whatever is returned by the function. So here's the thing. If I print c, I so need water. If I print c, you're going to see 9 and 10. I have to pass in the arguments. Okay, so if I pass in, you can see that the default value is none. So none is a special value that just represents nothing. It's very useful for like certain things. So how can we do it so that c is actually the result of our sum? We can use the return keyword. So the return keyword, what it does is it returns any value. It can be anything. So in this case, we do return a and b. So what will happen is the function will be called with 9 and 10. Then the function will sum a and b. So 9 and 10, it will return 19 and assign it to c. So let's see that in action. And we get 19. Question, how do you exit Vim? Okay, so that's actually easy. If you're in Vim, you just do 2 dots, Q, and you quit. It is quite honestly not that hard. Yeah, I am guessing that's not the answer that you wanted. For some people, I feel bad for the people who have been stuck in Vim for like millennia because they don't know how to exit. Okay, so going back. Oh, thanks. You're welcome, podcast. Fancy seeing you here. So, this is how you return a value. So you can use that value, for example, in its own function. So I can do something like D equals add C and 90. So I will do 19 plus 90. Oh wait, I forgot to print it. So I can print D. And that gives us 109. So as you can see, you can use a function and then use the value from the function on another function. And you can even have function calls inside function calls. What I mean by that is I can grab this, and instead of assigning it to a variable, I can just put it inside the other function call, like this. And it'll still work. So that's pretty cool. So yeah, those are functions. So then now I'm going to teach you about objects. So objects are kind of like values, but they're special values that can contain other values and can also contain functions to help you use those values. So the most common types are list, which is an ordered sequence of items. So, for example, a list is ordered, so that means that the order of how you put stuff actually matters. So you can have numbers, you can have ints, you can have strings, you can even have bools, floats, and even other lists inside of your list. And that's what's known as a matrix. So the way in which you access stuff on a list is actually by using these brackets and an index. So lists start from 0. So in this case, 9, at the 0th index we have 9. Then, we have 9. Then we have 10, then we have, at 2 we have asked. So I can do something like print, if I do print a 0, that will give me the first item on the list, which is 9. I can also do something like 4, which should be the 9.9. And as you can see, 9.9. Now, you have to be careful because there's only 6 items in the list. So what happens if I try to access number 6? That is actually out of bounds because remember, so we have 0, 1, 2, 3, 4, and then 5. So if I try to access this, it'll give me an error. It'll tell me list index out of range. So you have to be careful. And fun fact, in Python, you can actually, how to use method in Python and what are threads in Python what are threads in Python and how do they work? Okay, so a method is just a function that is inside of an object. So for example, I have a list. The list has lots of methods. So for example, pop. Pop is a method that takes out the last element in the list. So that is a method. So if I do print a.pop, that will return the list that is at the end of the list. So and actually pop actually modifies the list. So I can print the list, right? and then print the list again, and you'll see that it actually modifies the list. It removes the item and it gives it to you. So that is a method. A method is just a function that is inside of an object that belongs to an object, but they work just as normal functions. And threads are that is actually something that requires you to know a little bit about uh, like how computers work and how software works. So you usually have programs, but you can run programs. You can run multiple instances of the same program. So I can, for example, have two terminals open. So that is what is known as a process. And so a process is just a running program. And so every single program has a thread. So a thread is just, you can think of it kind of like a line of code. So for example, this code is single-threaded. What does this mean? It means that there is a singular line of code and it just goes through it in order. So it goes the list, then it prints A, then it prints A.pop, and then prints A. So that is a single-threaded program. And it runs one instruction at a time. The thing is, we can actually create many of these lines to run code at the same time, or make it seem like it runs at the same time. And that's kind of what threads are. So essentially, it's a way for a single program to run multiple pieces of code at the same time. However, you do have to be careful with multi-threaded programs. Nice. Update your resumes, people. Also, hello Kunal Chauhan and hello Geiger. Welcome. So, what else? So yeah, this is a list, and a list has methods. That's what makes it an object. So it's an object that has values and also has methods or functions. Then there's also dictionaries. So a dictionary is just it's a structure of keys and values. So what this means is that you have values. So here's the thing, it's not exactly a sub-process, because a sub-process is actually in an operating system is different. A program can create sub-processes or child processes and kind of have them do stuff. But at the operating system level, they're different, because a sub-process has its own memory and has its own code, its own memory, and essentially its own space. It's kind of like a container. It's its own container, separate from the parent container, but it can interact with it. Meanwhile, a thread shares memory with all of the other threads inside of a program, and they're actually less expensive because they're all inside the same container. If I had Paint, I should bring up like Paint or something. OMG, this is gonna turn into a pirate software stream. Okay, Paint. Nice. Oh, shit, what? Okay. So, in a very weird turn of events, Paint just doesn't want to show up. I really don't know why. That is very weird. I'll just remove it. Yay. Are you okay? Um, okay, I guess I'll kill Paint and I'll open. What is there? Paint 3D? Do you people remember when, like, Microsoft wanted to, like, replace the original Paint with Paint 3D? I mean, to be fair, Paint 3D is poggers. Paint 4D. Imagine. Let's go to the fourth dimension. Why is it not working? What the heck? Like, it just, like, flat out said, no, screw you. Not gonna work. I remember Windows XP Paint. Windows XP Paint was, like, the best paint. By far. It was fun to use. I remember using it a lot. If only I could get this working. As I have said before, it is never no extreme if something doesn't go awfully wrong. I know like nothing from just taking out like Clip Studio Paint or something. What the fuck? Yeah, now it's just like not wanting. I don't understand why. It just said no. Fun. Yeah, neither Paint nor Paint 3D like wanna show up. I have no idea why. No idea why. Okay. Yeah, sorry. I'm just like trying to get something I can draw on here on stream. It seriously shouldn't be this much of a problem. Like, seriously. Use Jamboard. What is Jamboard? I don't think I have that. Jamboard by Google. I guess I'll look into it if this doesn't work. Oh hey, that worked. Nice. Okay, so Clip Studio Paint does work. That's good. That's good. Okay, so let's see. Uh, the real question is, where did I leave my cable? Okay, here it is. Time for the Windows sound. Nice. Okay, so let's see if this works. Nice. Okay, so I'm gonna try to explain like processes and stuff. Okay, so imagine that you have your computer. So your computer, your operating system is kind of like this very big box, right? I should make it a little bit bigger. So it's like this big box, right? I hope it's properly visible. I'll just grab a big size. That's not big. Okay. So, yeah, it's like a huge box. And then every time you create a program, you actually create a box. And so this box contains things like code, which I'm going to represent in red. And it also has memory for it. And which I'm going to say is blue. So, what you can actually, when you have sub-processes, what you're actually doing is you are creating another box, kind of like inside the box, which has its own code, but most importantly, it also has its own memory, right? However, the two can actually communicate with each other. They can talk. So the child process can get information from the parent process and vice versa. So that's how processes work and sub-processes work. So then when you create a thread inside a process, what you're actually doing is you have your first thread, which is your main thread, but then you actually create like a second thread, for example, or however many you want, and you have one pool of memory. And essentially that's the difference. So this is when you have a sub process, I don't know how to type. This is sub. Imagine knowing how to write. That's a sub process. And this is threading. Now here's the thing. When you close the when you close the program, everything in here gets wiped, right? So if you close the program, all threads die. They're killed by the operating system. However, in a process sub-process thing, you can actually separate them. You can actually break. Where's my eraser? You can actually break the link between the two processes. You can actually break that link and kill only either the parent process or the child process and make them be independent from each other. So that is the difference between sub-process and threading. So I hope that was a good explanation, at least a good enough explanation. I wonder if they left during the entire thing. But yeah, then yeah, that's the difference. Can't wait for like the computer science degree person to come here and tell me, well, actually, you were wrong about this. And to that I say, as long as it's constructive criticism, I'll take it. Just don't be rude, man. But yeah. So yeah. I think I'll actually continue in some other time. Because, well, I mean, there isn't that many people here either way. Like, seriously, people. Oh, I feel like I've been talking to, like, Lamau, to be honest, is exact what you said. Oh, thanks. Nice. So, yeah, that is, so, yeah, that's how computers work. I think that computers are actually pretty cool. Like, I wish all people were computers. You know? I wish all people were computers. Oh man, well, I guess I can, like, I don't know, finish explaining this, the dictionary, because I don't have that much time, but I do have a little bit of time. Okay, so, I'm putting away my pen. So, you can declare a dictionary. So, what I mean by a structure of keys and values is that you have, instead of having numbers or indexes, I have no idea how you pronounce it. Sometimes I wonder how did they made matter to work. They taught rocks how to think. Humans are like stupid and so fucking smart at the same time. It is like genuinely impressive. So in a dictionary you have a key, which is what you'll use to reference the value. So for example, hello. And then you have a value, which is what's going to be the result. Now, the key can actually be any object that is serializable. What this means is actually not serializable, that's hashable, meaning that it can be hashed. That has to do with like how it works in the background. You don't have to worry about it. But you'll see the benefit in a second. So, for example, I can be like, I don't know, hello, world is equal to 99. Life 44.2. And then what else? And actually you can also use like numbers as indexes, like as keys, and I can print this whole structure, right? There you go. So here it is. This is the structure. So in order to access, you use these braces, but instead of passing a number, unless you used a number, you use the key. So for example, if I do hello, right, I get world, because that is the value associated with the key. So yeah. And then you can have any type of value that you want. So for example, you can have bools. You can have other lists, which in turn can have other dictionaries. So as you can see, it's a structure, it can contain any sort of value, including values of its same type. So you can have dictionaries inside dictionaries, lists inside dictionaries, dictionaries inside lists, just the whole assortment. You can even have other objects inside these structures. So it's pretty cool. So what these have in common is these are mutable. So what that means is I can actually assign new values to those. For example, in B, I can create a new key value pair by just doing B and then using the new key that I want. Shut the fuck up. And I can give it any thing, like for example, Knoll, and I can assign it to Chahan. And if I print B, and I print it afterwards, you'll see the difference, right? Oh wait, thank you for obstructing my view. So yeah, you can see that's now here. So that's what being mutable means that its data can be changed. So sometimes you don't want your structure to be able to be modified. You just want it to have certain data, but that's it. So that's where Python's tuples come in. So tuples are like lists, but immutable. So what that means is that data once you define a tuple, new data cannot be introduced, nor can data be removed. So for example, if I have a list, tuples are actually declared by using a comma. So if you do like this is a tuple. However, it is a common courtesy to have them around parentheses in order to make it easier to visually distinguish. So, if I had a list, I'm going to declare a new list, right? If I have a list, I can actually do stuff like, for example, I can append, which means to add at the end of a list. And I can have something like 34. So if I do something like wait, I'm stupid. Okay, so I can just have 34 at the end. But with tuples, that actually doesn't exist. So if I try to do the same thing, you'll notice that tuple has no attribute append. And also, if, for example, I can access the value that's at the first index. So I can change the 99 with an, 34. And if I do this, if I print C again, you'll see that the value will change. The 99 has turned into a 34. However, if I try to do the exact same thing with the tuple, equals 34, and we print B, if I try to do the exact same thing with the tuple, it'll actually tell me the tuple object does not support item assignment. So you cannot modify you cannot modify the data that's inside of a tuple. However, one thing that you actually can do is if, for example, I have a list that's inside a tuple, I can actually access that list and modify the content that is inside that list. So I can do something like this. And I'll print B to show what it looks like, and then print it afterwards, right? You can see that the value inside the list changed, but since the list reference is still the same, there is no error, so you can do something like that. It's pretty cool. So yeah, those are like pretty much the three main ones that you will be using. There's also sets, which are like lists but with a unique object, so you cannot have repeats. I can show it very easily. So for example, say I want to print a set. I can actually like create it from a list, and if I have duplicates, for example 12, 12, 99, you'll actually see that those duplicates are actually removed because the set only allows unique objects. It does not allow you to repeat values. So yeah, that's a set. It's pretty much the same. So yeah, those are data structures, and I think now it's time to call it a day. So, if there's anything that you guys would like me to teach next time, or if there's anything you'd like me to talk about, just leave it in the comments and I'll read it later. So, yeah, I'll be seeing you guys.